Hello, everyone. I'm going to be talking about elegant actor systems with xtra. And just as a heads up, this is not a WebAssembly talk. So although xtra does run in WebAssembly, but that's not kind of the point. The TLDR is that xtra is a Rust library, and in particular, it is an in-process actor library. And by in-process, I mean, for everyone who's familiar with Akka, Akka is a actor library on the JVM, but it's distributed. So you can run the Akka core on like multiple different machines, and it will distribute the actors on those machines and like send the messages back and forth. xtra is none of that. It runs in process, so there's no network communication and there's no serialization of the messages. And this allows us to fully take advantage of the Rust type system and at compile time figure out whether or not an actor can handle a certain message or not. As a disclaimer, it's not my project. I'm just a fan and contributor, although the original creator is in the audience, I believe. So that's good. I can direct all the questions to him later on. And the second one is there's a very high churn on the mainline branch, but the next release is hopefully very closely around the corner. So even for a TLDR, it was pretty long. So here's a TL SMTC. This is what the code looks like. So we define an actor struct, can have just a regular Rust struct, can have arbitrary data in it. We implement the actor trait on it to define some lifecycle behavior. Then we define a message. What's interesting to see here is that this message can be any type. It doesn't need to implement a trait. Can be a standard library type, can be a type from a different crate, whatever. And then we implement a handler. And in the handler, we get mutable access to our actor. We get the message and the context. It's an asynchronous function, meaning we can natively integrate it with asynchronous code like the request library to send a network request or anything else, and return a response. And when we want to use it, we just create the greeter, spawn it into the global runtime. In this case, it's Tokyo. We send a message to it, we await the response, and we have the response. So a lot of you might ask, like, how is this any different from just using Tokyo spawn and spawning like an async task? Well, in a way, you can think about these actors as that they're tasks on steroids. So in Rust, with its ownership model, if you have a task or a future and you give it to a runtime, the variable is moved, so you no longer have access to it, meaning you can't access anything on that future to pass more data in once it's started to execute. And in a way, an actor is a task that you can send messages to after it's been spawned. Now, of course, you could just say, oh, okay, I'm just going to put like an MPSC channel into the task, and congratulations, you've written yourself an actor framework. All right, so xtra is really just a thin layer on top of the Tokyo or any other runtime. It works with any Rust runtime, I believe, actually. Even in WebAssembly. So the second advantage is that it has defined lifecycle functions. I'm pretty sure we're all familiar with the good old "have you tried turning it off and on again" saying. Well, that doesn't just apply to consumer electronics. We can apply the same thing to our code and encapsulate any sort of fallible process in an actor, and have another actor on top, which is called a supervisor, that just monitors whether or not that actor is still alive. And when it stops for whatever reason, we can just restart it. And this was pioneered by Erlang, I believe, which is a really, really great way of writing resilient software. The third one, maybe a bit of a strawman argument, but it's like we can name all the things in our code if we use a library like xtra. And that makes it really easy to just navigate around the code because it's not just littered with Tokyo spawn of async tasks, but everything has like a nice name. The actor represents a concept, and it's a nice encapsulated module. Another advantage is that xtra is very modular, so you can sort of pick and choose the parts that you need, which allows you to have very easy instrumentation with things like Prometheus or Jack. To finish, or not to finish, but like next, I want to talk about some patterns that I've encountered in working with xtra. So this one I call the send message to yourself pattern, very creative. And we have another actor here, and we have a message. And in here, we override the started lifecycle function of the actor. We grab an address to ourselves, and we spawn a task away where we just send a message to ourselves every 100 milliseconds. An important thing to note here is that just because you're using an actor library like xtra doesn't mean regular tasks no longer have like a justification. As we can see, this like nicely blends into each other. We just spawn a task where we send a ping message every 100 milliseconds. And once that errors, we drop the task. Otherwise, we'd have a memory leak. And now you have like a nice module that you can put in a corner, and every time you need it, you just like instantiate the actor. It's nicely encapsulated. It just does its work, and you can later send messages to it. And this, in fact, brings me to the second pattern, which I'd call a local cache proxy. We found this really interesting. If you, for example, have a remote resource that is expensive to fetch or expensive to interact with, you just write yourself an actor that encapsulates the access to that resource. So on some kind of interval or some other trigger, you just fetch that resource and you store it in the actor. And every other actor will just send a message to that proxy whenever it wants to interact with that resource. But instead of triggering a network request, you just serve a local copy of the cache. This is really great because it means that you're not going to trigger n network requests if n actors ask for a copy, and you have very defined access behavior to that expensive remote resource. So as a wrap up, xtra is an in-process and type-safe actor library. It's got a really small footprint. I think we're at like, 3,000 lines of code or something. It's Eizinger weight native. It works with every Rust runtime, even in WebAssembly, which is great because this seems to be like a WebAssembly meetup. And it's also very modular, and we're working on making it even more modular. We're also working on adding benchmarks to it, like we've done a couple. And at the moment, it seems like we're like just a very thin layer on top of on Tokyo. But yeah, there's going to be some hard numbers on like how fast it actually is. You can find all the code on GitHub. There's also a Matrix channel that you can join if you want to chat with us while we're developing. And yeah, I'm happy to answer any questions. I don't think that at this stage there's any plans to move it out of process. I think that there would be, I think at that point you'd probably look at something like Lunatic, which is going to come after this talk, which I think has a distributed mode where you can move off processes to other machines. I found it really helpful to use xtra in a way. If you have a program that has requirements where you have multiple entry points, let's say you've got an HTTP interface, you've got a peer-to-peer interface, and you've got some kind of background processes, then it's just a really nice way of modeling that entire program, because not one component is like dominant in the design of the application. If you take the Rocket Web Framework, for example, it kind of does take over your application. Like if you use Rocket, your application is primarily a website or a web service. And so integrating another component in it that sort of has like similar level of priority is kind of weird. Whereas if you use something like xtra, it's just basically everything is an actor. It's really easy to write actors and shove them into their own crate and then compose your application together. So I think there is a space where we can have this actor in-process library where it makes sense to structure your applications that way that doesn't necessarily have to be distributed. Another question is, are there any patterns for running blocking CPU-intense code in actors? Well, same pattern as with Tokyo. So if you want to run blocking code, use spawn blocking. Generally, because xtra works with any runtime, it sort of depends on how your runtime deals with blocking code. I think if you use async std, they detect if an executor thread is blocking and spawn a new one. So if you use xtra with async std, you don't really need to do anything else. If you use it with Tokyo, you're meant to use spawn blocking. If you use it with WASM bindchain in WebAssembly, you probably don't want any blocking code because it's going to run in a single thread environment. So it just depends on the executor you're using. What are the advantages of this over Actix? Looks like it's easier to read, but it's been a while since I've written Actix. I've been waiting for this question. So the advantages over Actix are that it's async await native. It does not come with its own runtime. So Actix comes with its own runtime, and it also comes with a fair bit of unsafe code. There's not a single line of unsafe code in xtra. And Actix predates the async await era of Rust. So working with asynchronous code is kind of weird in Actix because you've got this like async handler thing, and then it's sort of like an extension to a future where you also get the actor reference passed in, and so it's just not as ergonomic. And in general, it's just much smaller footprint and tries to do a lot less. Like xtra will probably never have a dedicated web framework attached to it because you can just use any web framework you want and just take the message and dispatch it to an actor.